All right, welcome back, ladies and gentlemen, and this is a review of linear key features. So, on the work y'all have been doing, y'all will be seeing a review that looks a lot like this. It gives you a function, gives you all the key features, and it asks you basically to go from there. It also gives you a graph, which I tore off the worksheet, so we'll be graphing one. And it just has you list all the key features. Oddly enough, yes, most certainly can you find all of this information and a graph from just this function. Okay, so here's the function g of x equals 3/5 x plus 3. Okay, the first thing we need to recognize is that this is written in a particular form for linear equations. It's actually written in slope-intercept form. Okay, so if you recall, and also on your formula charts, slope-intercept form tells you y equals mx plus b. Well, here's m and here's b. Okay, and so remember, m is slope. Okay, so slope is represented by the letter m, and this equation literally hands it to you. Okay, so m is just the coefficient in front of x, always, for this form. Okay, so our slope here is going to be 3/5. Notice it's positive. If I saw a negative out here, I'd make sure my slope is negative. Okay, there's one more piece of information handed to us, literally handed to us by this equation, and that is right here, the b. Okay, b is your y-intercept. Okay, so here in this case, b is 3. Make sure if you get something different, like a negative sign out here, subtraction instead of addition, then you make sure that your b, your y-intercept, is a negative number, right? It'd be like -3, but this is just a +3, so we're going to write that. Also, in other kind of cases, you may just get 3/5 x with nothing out here. You can assume this to be +0. If there's nothing out here, assume this to be +0, and that would be your y-intercept, 0. Okay, so we've got our y-intercept and our slope. And from here, there is one more thing from this equation that I could definitely get fairly easily. But first, we're going to graph it. So I'm going to pull out this torn out section of graph. And I want y'all to remember these things, because I'm going to zoom in so we can see what's going on this graph. So if y'all recall, from what we just looked at, our y-intercept is actually going to be +3. So that's going to be the first point I put in here. 1, 2, 3. There's the y-intercept. There's the coordinate point. Cool. Now, knowing that my slope, I guess I'll show it. My slope, my m, is 3/5. This is rise over run. Okay. So going from that point to get to my next point, I should just be able to do my rise over run. So my rise is 3, up 1, 2, 3. Run is 5 over 1, 2, 3, 4, 5. There's the next point. Okay, and that would be it. And then I just use a straight edge, or you can substitute paper. Use a straight edge to draw the line. Now, unless the line gives you a restricted domain on purpose, you can assume, given a line like that, that you're going to have arrows on either end of your graph. So seeing this, okay, it appears as if my y-intercept is also a very pretty point, meaning it's just a simple point you can tell lands exactly on that spot, and it turns out that it is. Okay, so your y-intercept, I'm sorry, not the y-intercept, the x-intercept here, the y-intercept's up here. X-intercept here is a pretty point, and it lands specifically on that one spot, which is -5. So I'm going to zoom out here, and we're going to go ahead and fill that in. And then I'm going to show you guys how to get that if it's not a pretty point. Okay, so our 0 here, our x-intercept, is -5. It's this point right here on the x-axis. But what if it wasn't given to you like that? Okay, what if it wasn't that simple? No problem. if you remember your definition and taking this function y equals 3 over 5x plus 3. Okay, all I did was change g of x to y. Okay, they are literally the same thing. Okay, and I'm allowed to do that. It's just a different way to notate the function. Okay, so if you remember from the definition of your x-intercept, or the zeros, it's where the function, the graph, crosses the x-axis and the y value is 0. So if we force y to be 0, we will set the conditions for this equation to give me the x-intercept. Okay, with the y value of 0, then I just have to solve for x. So I'm going to subtract 3 from both sides. You get negative 3 equals 3 over 5 x. Now I have to multiply both sides, get rid of this denominator first. So I'm going to multiply both sides by 5, and that's going to cancel those 5s. So that's going to be negative 15 equals 3x. And then divide both sides by 3, and that's going to give me negative 5 equals x. So there's my x-intercept. Okay, we get the same thing. All right, next thing you need to look at is the domain and range. Well, looking at this linear function, the graph, we want to ask ourselves how far, looking at domain, which is always going to be the x, okay, range is y. So we're going to ask ourselves how far to the left is this thing going to go? How far that way is it going to go? Okay, it's going to go down and to the left, down and to the left, down and to the left, forever and ever and ever. So how far is it going to go just to the left? Forever. Okay, it will continue to go to the left forever. This function will. So it's going to be from negative infinity. Now look at x, and how far is it? It's going to go up and to the right, up and to the right, up and to the right, forever and ever and ever. Okay, it's going to keep rising and running by 3/5 every time. So how far to the right is this thing going? It's going to go that direction forever. So to positive infinity, or you can say x is an element of all real numbers. Okay, this is the way we like to see it. This just means x can be any number. Okay, there is, for every input x value, I will get an output. Okay, there's no value of x I could put in here that wouldn't give me a y. Okay, so x can literally be any number. All right, now let's look at y. How far down is this thing going to go? Well, it's going to go to the left and down, left and down, left and down, forever and ever and ever. Okay, so it's always going to be going down. So negative infinity to how far up? It's going to go up and right, up and right, up and right. Okay, so it's going to be to positive infinity, or y is an element of all real numbers. Okay, this is continuous domain and range. Okay, because this is a continuous function. It's a line, not a set of dots. So because each dot, each piece is connected by this line, every value on there is part of this function, which means it's continuous. Okay, and also for the last and final piece on this review is very down here, it'll say increasing, decreasing. This is something we haven't really talked about. But if you just look at the line, okay, and you look at it like you're reading a book, you always read left to right. So if we go this way, are we going up or down from left to right? We're going up. So that would mean our function is increasing, okay? It's got a positive rate. All right, and that's review of key features.